What's going on, everybody? Zane here, back with another video. For this one, we've got question number 133, which is a clone graph problem. So this problem is based off of the DFS keyword. So we're going to be doing some sort of depth first search function here. So when it comes to DFS, let's first take a look actually here, where we have the definition of a node. So what we're doing here is we've got a graph which is going to be passed in through some sort of node, and that node is going to have a specific set of characteristics, which is going to be its value, its neighbors, and we have things overloaded such as the value here and its neighbors as one part of the constructor versus the other here. So really we just have the value and our neighbors that we need to really worry about here. So just keep that in mind, that that is the property of a node. So I'm just going to move this out the way. So here our task is, let me get this out there as well. Given a reference of a node in a connected undirected graph, meaning that they can go both ways. Undirected means like back and forth. What we need to do is return a deep copy of the graph, so a clone. We cannot do references. We cannot just return the node that we're given. We must give a clone that has new nodes, but the graph looks exactly the same with the nodes in the proper places. So to tackle this one, we're most likely, or what I'm thinking here is that we could use a map. And the map here is going to be used to track the node and the value that we're currently at. And what I mean by that is, if we were to go through all of these nodes, they would have the actual value and then the node itself. So what we could do is we could first get the base case out the way. So if node is null, just return null. That's always going to be the case because we're returning a node here. So just return null if that's the node is also a null. So what we can do now is create that map. We'll say a map of type integer and node is going to be a map, and we'll just say a hash map here. So we're instantiating this map to have a key of an integer and a value of a node. And then what we want to do is, since we're using DFS in this case, we can create another clone graph function and essentially overload it. And that's what we'll return. So we'll return a cloning of the graph, passing in the node and the map. And then inside of our second function here, which will also return a node, we're going to pass in a node and a map of integer and a node. And let's call this map. Now what we could do here is, okay, we're kind of using our map as our starting point. So we'll say that if the map contains the key of, and the key here is going to be an integer, so it would be the node's value. Then what we would want to return, it means it's already in the map, so we want to return the actual node, which is going to be the value. So we'll just say map.get the value of node.val. So the value again is a node, which is why we're returning it. Now, the reason we're doing this here, we're using a map, yes? So by using this map, we can continuously check whether or not we've already added that node and its integer value. But since we're doing a DFS function here, we need to account for our base case, which is why it's called recursively, so that we can continuously call it without it having breaks at some point in the code. So once we've taken care of our base case, what we want to do now is let's create a copy of our node, because essentially that's what we're doing. So the copy would just be a node, and we'll call it copy, which will be a new node of exactly what node.val is. Now this is where this piece over here comes in, where deep copy. We're not necessarily pointing to our existing node, we're not returning our existing node, we're just creating a brand new node which is of type node.val. So we're copying that, but it's still a brand new node. Now what we could do is we can add the value of our node as well as some integer value to our map. So again, taking a look at our map, we were passing in a key of an integer and a node as our value. So the value will be the node.val, and then our node is just going to be our copy node. So what this is doing is it is essentially mapping the value of the existing node's value with our copy, so that we know where exactly, let's say if we were using this, we're saying that the node value 1 is mapped to this copy node. Once we've copied that over, now we can do our recursive call. Now, to do the recursive call, though, we need to first go through all of its neighbors, which is why we need to check the bottom, we need to check the right, and then we need to be able to recursively call from there. So we'll loop through all of our nodes. So we'll say for every node, and we'll call these neighbor nodes, and we'll go through all of the initial node's neighbors. And we're going through all of these nodes here, and we're saying once we're at a specific neighbor, we'll say we now want to add these neighbors to copies neighbors. So we'll just say copy.neighbor.add, and then we can do our recursive call using our neighbor and our map. Once we've done that, we can just return a copy of our node, and that should do it. Let's just submit this to make sure it's good. Yes. So you can see I've tried it 1,000 times, but this one was a tough one to kind of wrap my head around. This is me kind of just redoing it as practice so I can talk it out. But what we're doing here is, our first thought is how can we clone something? Well, we could create a new node that is based off an existing, which is why we're doing this here. But big picture, what we want to do is we are mapping the value of this. So we're mapping 1 to be at this particular node. So again, we're looking at this map. The integer here is this value of 1, and that is mapped to a node, which is this entire node. So the value of 1 with this entire node. So we're just creating some random map here, making sure that if it's null, then return null, but otherwise we'll go jump to this overloaded function. And this function, this is essentially our DFS, where we're saying that if the map already has the node, okay, then just return the value of that, return the node inside of the map, because it's a public node. But if that's not the case, then okay, now we can start doing stuff. Doing stuff is where we start copying. We'll put the copy, and then for every single node in the node's neighbors, we'll add that to the copies neighbors, and that add is going to be whatever the clone graph recursive call is on the neighbors. Now this right here is just the most the largest learning curve, because for me, it took me a couple of times to really understand what's going on. We're going through all of the neighbors of the existing node and copying those neighbors, or adding those neighbors to the copies neighbors by recursively calling on the neighbors and map. So that's why we needed to put the value here, because once we've done the copy of the original one, okay, then now we can go through all the values, and now we can do the clone of all the rest of the values, because this recursive call is going to keep putting values and keep creating copies. And then once all that's done, once all the iterations are done, we can finally return copy, which is just our node. Anyways, guys, that's it for this one. If you have any questions, comments, feedbacks, please let me know in the comments below. Otherwise, hit that like and subscribe button, show me some love, and I'll see you in the next one. Peace.